In this lesson, I want to show you the relationship between the atmosphere and different sizes in the scene relating to terrains, the display unit, and also that in relation to the sea level. So to start out, what we're going to do is load in an infinite terrain. And the easiest way to do that is to right-click on the procedural terrain function, or the button to add a procedural terrain. If we right-click, it's going to open up and give the ability basically to just load a terrain in general, whether it be a procedural terrain or an infinite terrain. You can also create and save your own infinite terrains, which I'll show a little bit later. So I'm going to start by loading in the default infinite terrain. And it's going to ask a couple of questions. In this case, we have a ground plane. It's going to ask if we'd like to remove that ground plane. I'm going to click yes. And also whether or not we want to have the sea level. I'm going to click yes. That's not going to render, but it's going to be important for setting the atmosphere. So the procedural infinite terrain is loaded in to the scene now, and it's going to extend to the end of the render area or to the horizon for as much as needed. So in other viewports, if we double click on the bar or go up to the top, and you can switch between the 4 viewport mode. If you go to the top view and zoom out, eventually we will see an end of the terrain, but if you were to move the camera and select the camera using the move gizmo, and if you don't have gizmos turned on, you can go to display gizmos and turn on show gizmos. If we move the camera over, you can see the terrain moves with it. It is a world-based function, meaning the coordinate system will continue forever. You may also notice that there are a few polygons cut out of this preview, and that's because my OpenGL display distance is not quite high enough. So it's a good idea to set that. Go to File and Options. And under Display Options in the lower right, we have the OpenGL clipping range. So what we can do is set this to the near plane distance has to be set to a certain amount first before we can increase the far plane distance. So I'm going to set the near plane distance to 1 meter, and then we should be able to set the far plane distance to 500 kilometers. I also want to note under units and coordinates that I have one view unit is equal to 1 meter, and the display unit is the metric automatic mode. So if we take a look at a render right now, we're going to see a very hazy environment. You can just see with a small render here. I'll go ahead and render something a little bit larger for you to see. So as you can see, it's pretty light. The density of the atmosphere is really high. Now, there are a lot of factors to this. Obviously, the gamma has a lot to do with it. Right now I do have the gamma controls turned on, and I have the post-render options open, which is currently set to show whenever the render completes. If I close that out, if you don't have it open, you can go to the post-render options up here, second button from the right, and you can edit the gamma correction. If we go ahead and set this to 1 and click OK, 1 is the typical gamma output of view. But of course, you can change it to whatever you want, depending on the lightness of the scene and contrast overall of the different elements. I've got mine set to about 1.4, which is what I typically work with for the output of renders. Auto exposure is turned on in natural film response. Natural film response is a sort of a clamping mode in a way. It mixes the highest portion of information with the highest contrast with the lowest contrast information, gives a more of a balanced image. Just to kind of sum it up, it prevents overexposure, basically. If you're working with 32-bit images, like an EXR or HDRI, then you would want to keep that natural film response turned off, because all of that extra information is already in the file or in the image. This is really a way to take those different levels of information from a 32-bit and display it for an 8-bit or 16-bit image, which is what we're seeing right now, is an 8-bit image. So I'm going to go ahead and close this out. If we select the main camera, which I already have selected over here in the right, with our layers view, and we take a look in the aspect tab, which is in the upper right, there's a couple of different options. If we take a look at the height, we can see we're currently 70 meters above the objects that is directly under the camera. In this case, it is the terrain. So you can actually set the height of the terrain or the camera with this. If I was to go ahead and set this to 1.6 meters, it's going to lower the camera to set on top of the terrain. So switching over to the 4 viewport mode, go ahead and see our camera, and then it's just resting on one of those, or close to one of the peaks. So this line that we're seeing in the front view, that is the sea level. Now the X that is currently showing up on the sea level icon, that's the trigger to hide from the render, which shows up as a little ghost up in the aspect tab underneath the preview. So you can either check that on or off by clicking on the icon, or up there with the ghost. So now the sea is going to show up. We can see rendering. So the sea level right now is really high. So when we adjust the sea level, it's going to change the density of the atmosphere. If we go ahead and bring the sea level under the terrain, we can see a much more clear view of the scene. Now we see a more concentrated atmospheric, in the distance, more of a blue haze over everything, which is the atmosphere itself. And I also want to note, I'm going to go ahead and close these out. I did not mention that before, that I am using the standard or the default atmosphere, which will load automatically with a new scene, or when you open view. Whenever you select File New, it will open up this window, but if you close the scene first and select New, it'll automatically create the default atmosphere. So this is the one I'm using. Now I'm going to get into the details of the atmospherics in the next section, but I do want to do just a quick overview of some of the important things for the atmosphere. So if we go to the atmosphere editor, what we're going to see in the Sky, Fog, and Haze tab, and I am working, this is a spectral model, which is going to be the most commonly used model within View when you want volumetric clouds and realistic lighting. It is 100% volumetric atmosphere. All of the different settings in this tab, including clouds, are primarily affected by the sunlight, which is a distant light in the scene. That can be controlled under the Sun tab for the azimuth and the pitch. And when we take a look at the scene, the overall density of the atmosphere for what would be the most realistic is, at least on Earth, the setting for the aerial perspective is set to 1, is what would be a realistic atmosphere. What we can do is increase and decrease the aerial perspective in order to increase the density of the atmosphere. So if I was to increase this to 10, what's going to happen is, because our camera is so high up, we've actually gone outside of the atmosphere. And even setting it to 2, we're getting closer and closer to basically being in space. So we could also reduce that to make ourselves look lower to the ground. So I'm going to go back and set that to 1. Now, the aerial perspective increases the density based on the other settings that we have in here. The fog and haze, and then the glow intensity, which is basically is going to adjust the spreading of light throughout the scene, how much it spreads out throughout these different atmospherics. The sky mean altitude is going to be not the absolute height of the atmosphere, starting from the sea level, but what it is the mean altitude and the point in which it starts to fall off. Same thing with the decay, which is what we're going to see as a darker color along the bottom, and which creates the sunrise. Or the color that we would see at sunrise being more red, that being the decay, which in this default scene is set higher than the sky itself. And then we can also set the density of the overall sky. We'll take a look at those settings in the next section. I do want to cover some of the primary factors of the infinite terrains first. Because the randomize button for infinite terrains doesn't really seem to have that big of an impact due to the vector number from the seed not really being high enough. What we're going to do is customize our own. That's going to work a lot better. It's going to be more powerful and give a much higher vector output. Right now, these numbers are staying pretty low. So what we want to do is add in first a math node. So right click, go to math node, go to vector operations and set offset, which is the top one. And then with that selected, what we can do is select the link between the Vector3 seed and the position, add a math node over from the left, which will automatically add that offset to the link. We can take this Vector3 seed and we're going to select the link to the offset and delete it. And then we can grab from the bottom of the Vector3 seed the output and connect it to the output of the offset. So the Vector3 seed does not need to be connected to the position. It's basically an offset of the position internally. So now if we connect the offset to the Vector3 seed, it should basically return the same output. What we need to do is make the Vector3 seed more powerful. So I'm going to take this other offset that we added in earlier and change that over to Randomness Vector3 Seed. You could also select the Vector3 Seed, the other one, Control C to copy, click off of it to get the red box, or depending on your color scheme, it might be a different color, and then Control V to paste to add another one if you want to do it that way. What we're going to do is select the link between the offset, which I extracted and connected to the Vector3 Seed. I do have the links turned on to always show the outputs. If I zoom in a little bit more, we can see all the outputs on the side. If I go ahead and turn that button off, we're not going to see any of the outputs, and then what we have to do in order to get them out is to extract the parameter. But I do want to keep that on, and also when we go to the options here, I have automatically map connected parameters turned off. So what we can do is take this output, grab that link between the offset and the Vector3 seed, and we're going to add a combiner node. Now, depending on the last combiner node that was selected, it might not be compatible. So you may need to click off into the red box and then add the combiner node and switch it over to Blender. What I'm going to do is select multiply, bring it all the way to 1, and take input 1. Input 0 is connected to the other Vector3 seed. We're going to take input 1 and connect it to the Vector3 seed that we added, the secondary one. So we're multiplying this number by this second number that will be generated once we click Randomize. So what we can do is go ahead and click OK. And now when we click Randomize, it'll give us a much more changed terrain. And I'm going to go ahead and just change my brush over here because that mask and everything is kind of interfering with the look of the preview. I'll be going back to that procedural and clicking Randomize. We now see a nice change, whereas before it was really not changing very much. It was just slightly shifting the features over. So we can make this work a little bit better because I am noticing some similarity between the randomization. So what we want to do is break down this vector and basically prevent negatives from happening. So what I want to do is add in another math node, right-click, math node, go to Vector Operations, and choose the Decomposer 3. What this does is it breaks down a vector output or into its input, and so we input in a vector which is containing three numbers, the x, the y, and the z, and it creates three outputs which are number outputs, one for the x, one for the y, and one for the z. This way we can go into the individual axes, the x, y, and z, and manipulate them on their own, and also use filters that are not available for modifying a vector. They'll only be available for numbers. So I'm going to select the Decomposer 3, Control C to copy, click off of it, Control V to paste, disconnect the link that was to the Vector3 Seed, and we're going to change this from the Decomposer 3 to the Composer 3, which takes those three numeric inputs and converts it back into a vector. So now we're going to take the Vector3 Seed, or the link from the Blender, connect it to the Composer, and we're going to set up a couple of filters. We can see over here on the left, the F, add that in to create a filter, making sure that you have that red box setting where you want to put the filter. And we're going to change this over to the floor. What this does is creates a minimum value that is allowed to come through this Vector3 Seed. So we have a negative value of negative 39 on the x. So if we connect the floor to the x, and if we take a look at the output observer, and we take a look at the link, our automatic extension is turned on, so what's grayed out, it says 939, because it's automatically extending the range of the node preview. So by selecting the link, we can see what the output is until it reaches the floor. Since the floor is set to 0, it's not going to output anything higher than 0. Now we don't want to multiply it by 0. We want to have a minimum value. So let's go ahead and set that to 200. And then I'm going to copy and paste two more and disconnect the links because those are going to be connected to the x. So now we're going to connect the second one to the y. And once we select that link, clicking and holding down, drop over that highlighted circle, then we can choose which output, so z. So now we have a floor for x, y, and z. We can change these values and make them different, but making sure they're not 0, making sure they're higher than 0. We could even take one that's, in case we end up with, say, a negative number. Let's say we want to basically divide it. We could use a decimal, 0.01. So multiplying it by 0.01. And now we go down to the Composer, and if only one input is showing up, which is what just happened, you can select a node and just kind of move it side to side, and then the three inputs will show up. Sometimes it just doesn't refresh, and if there's more than one link and it's only showing one, you can just move the node, and typically those other links show up. So now we're going to start and connect the x, the y, and then the z. So just as long as each one of those is connected to a different floor, it really doesn't matter because this is just a randomization. So the order doesn't matter since we know each floor is connected to the XYZ. We could go beyond this and add another blender between the numbers and maybe have one multiply another internally within this. But I think this should be a good amount of randomization. One thing we could possibly do is I want to show another randomizer. So if we go to Metanode, randomness, we can select the scalar seed. Now what this does is it takes a number. We're going to connect this to the Z, and then take that link from the floor, connect it to the bottom of the scalar seed. It will offset the value. In other words, in this case, it will add, and then that number is randomly generated once we click the randomize button. So that's going to basically add a random number to the Z to go along with it to be multiplied by the Vector3, other Vector3 seed. So we can click OK. And now when we click randomize, all of those different actions are coming into play. And we get really nice variations within an infinite terrain using a much higher vector number. So if you wanted to make this available for all of your terrains, you could create a Metanode, which is a container for all of these nodes. And what we need to do is select all of the different nodes, and because we do have two vectors going into this offset, and I do want the offset to be part of it, I don't want to have two separate outputs that I have to connect outside the node. So what I want to do first is just have a single link. So we're going to use connectable constant. Right-click, go to constant node, select connectable constants and constant vector. We can then connect the output, extracting that value, connect it to the offset, delete that constant node that was created from extracting, and then take these links from the offset and connect them to that constant vector. This way we have a single input that we can use when we create a metanode, and you'll see why that makes sense once we get to this point. Now, if you were to reload this or load it into a scene, you wouldn't need to worry about creating this constant vector. It's really just a way to separate for the metanode. So once they're all selected, this entire top group, we can go up to the top and create a metanode from selection. And let's call this Mega Random Vectorizer. So now what we can do is save this out. And I'm going to call this, or give this a version of 0.1. Save it. And now if we go ahead and open up the node and we take a look, there's an output going to the constant vector. Now if I would have had those other two links connected to the offset, there would be two Vector3 outputs. So if we take a look at the outputs available, it's a Vector3 output, which is a vector output, a Vector2 output, which is a texture coordinate, that's the purple links that show up, a double output, which is a number output, and then a color output, which would be a green link. But since we're really just working with vectors, all of our numbers are internal. We don't need any outputs for them. So the position name we should keep, but this name for the output as constant vector, we should just call it vector. Actually, we can call it position, making it the same as the top, and that way we remember to connect the position inputs for our nodes to this. Click OK, and I'm going to save over the version I just made. So now if I was to disconnect the constant vector, and we go to connect this terrain fractal which got removed, drag it over the metanode, and because the only option is that one output, we don't get a list to choose from. So really, whether or not it's named position, I guess it doesn't really matter. But when you hover it over it, will say to the position, link from the Metanode. Click OK, and let's hope that the randomization will work within the Metanode, which it might not. And it looks like randomize is not going to work within the Metanode. So what we need to do, and it looks like it added a new Vector3 Seed, so that probably needs to be outside, but that's alright. We can have an additional seed. That's okay. All we need to do is whenever we load this in and add it to the top, we just ungroup the metanode. So to load in a metanode, you can right-click, go to Load Metanode, select the file. If you have it saved to your content directory for metanodes, they become available in a list. So if I go to Add Input Node, Metanodes, here's a list of my metanodes. These are from Snowflake in my custom metanodes. So if I was to add this to the folder for that, so this is within my installation folder for the content, and folders that are not there for types of nodes can be created and added, because by default a lot of these don't have metanodes or won't have a folder for them, but once you create a folder, they'll be available within the interface. We can go to the input, double click, and I already copied the file from where it was originally saved. We can paste it in, and now Mega Random Vectorizer is saved in the content directory. So if we right click in the function editor, go to metanodes under input, we should see the Mega Random Vectorizer. So we can click on that, load it in, and once that's in there, you can ungroup it, which is the button right next to Create Metanode. So then it'll automatically set everything up, and now when we click Randomize, it will work. So it just looks like the randomize buttons don't work within metanodes. If needed, you could publish the parameter of the metanode, but then we would have to not use seeds. We would have to create our own custom generator. And that would be basically adding in, right-click, constant node, random constant number. So we would set a minimum and maximum amount, and then when you click reset, it changes the random number generated between the number 0, in this case 0 and 1. So if we set that to 5,000, it would generate a number between 1 and 5,000. Right now it's 212. Looks like now we've got 2,652. So looking at the automatic extension, if you check off autumn extension, you can click in the extension and see the actual number being output by it. So what we would need to do in this case is remove the connection to the Decomposer 3 and set up a random constant number for either connecting all of these, since the floor value is randomized, or create one for each of the different axes, x, y, and z, since these are broken down into numbers, and this only works as a number. And then we're going to publish this reset button. We're going to put it in a group called Randomize, and we're going to call this Seed. So now, when we click OK, a new tab is going to show up called Published for published parameters. We click that Seed button in order to randomize and change that value. So now this is only changing the X. It's not going to change the other seeds, But it's just another way to create random seeds. So if you had one for x, y, and z, you could randomize the x, randomize the y, and also the z separately. Just kind of something neat you could do. So that ends up working a lot better than the built-in randomize for the Vector3 Seed, which doesn't quite seem to output a high enough number. So we could also mix the different infinite terrains together. So if we wanted to mix this with another one, we could right-click, and let's go ahead and choose the brown strata, click OK. Select No to replace the existing terrain, and that way we can have both of them. And then we can adjust the height, kind of mix those together a little bit. So we've got two terrains. Refresh the sky if needed. I also want to note that you can go below sea level. So if you wanted to take the sea level object and raise it up above the terrains and above the camera, you can get some pretty interesting looking hazes and things like that. Grain does tend to increase. So one thing to pay attention to. Just because the contrast levels are so high at that point. Something that's really important though, and just going to cover that really quick before finishing up this section. The sea level is basically 0. So if we add a cloud layer, and go with Spectral 2 under Clouds, let's go ahead and select Dark Cumulus. It does look like there is a little bit of a display error. It looks like maybe the sea level object is not updating properly. So the height of the sea level is -9 kilometers at the moment. If we go to Options, it is showing correctly under Units and Coordinates. But the cloud is not letting me go below that amount. So I think in this case what we're going to need to do is just grab all the objects, sea level, default, and brown strata, and raise those up higher. So that we're above, and then our main camera will also need an adjustment. And whenever the main camera is selected, if you go to use the zoom or the scroll on your mouse, it will not let you move the camera. So just deselect the camera, and then it'll work again, in case you navigate that way. Refresh the sky. So it looks like we just need to avoid having the sea level too low, at least below what would be considered the ground plane. So now if we select that dark cumulus, we can move it all the way down to the sea level, which is going to act as 0. Like I said, it looks like there's a small OpenGL error with the showing where the clouds are. That should be fixed soon. I'm going to try to just reload that cloud layer and see if it updates properly. And it looks like it's not. So let's go ahead and set the sea level to 0. And now the object and OpenGL are matching correctly. So in the case where we're not working with a spherical scene or a planetary terrain, it looks like sea level should really be at 1 or at 0, and then you should probably adjust your objects in relation to that rather than adjusting the sea level. So what we can do, go to the options. If we want to turn on a spherical scene, we could do that. And just see if that affects the other objects, just really quick. Okay, so it looks like when spherical scene is turned on, there aren't any problems. So if you're not working with a spherical scene, keep that sea level at 0. but it should work properly with the other types of scenes. So next we're going to take a look at the different atmospheric controls and how to get the kind of atmosphere that you want, customizing the different spectral settings, and taking a look at clouds as well.